Hi friends, let's have a look at today's daily challenge problem. Problem 2583, Kth largest sum in a binary tree. For this problem, actually it's rather straightforward. So we are going to practice level order traversal. So before we start, so we want to point out that these three problems, so they can be solved by almost identical code. So I would suggest that after you do this problem, 2583, you can also use the same method to try the other two, right? So here the problem statement is that we are given a binary tree and a positive integer, right? So we want to find the kth largest level sum. If the number of levels is less than k, so we're going to return a -1. So in example 1, if you check the level sums, you get 5, 17, and 13, and 10, right? So the second largest will be 13. That's the return. And in the second example, so we have 3 levels. So the level sums are 1, 2, 3, respectively. So the largest one will be 3. So it's also possible that the k is very large, larger than the number of levels. For example, if in example 2, you choose k equals 10, right? Then you are going to get -1 for the return. So with that said, we are ready to look at code. Actually, there's a pattern here for doing those in a very standard way. So here we just want to demonstrate one way, right? So we can actually get all the level sums just for explicitity. So we have level sums. So also notice that the number of nodes is at least 2. Right? So in other words, we can directly define a level containing the nodes of the current level, right? Then we can use a simple while loop. So while level, then we're going to get the sum of the current level and then go to next level. So for getting the sum is rather straightforward. We can use a list comprehension, right? So sum of those. So basically it's a node value for node in current level, right? So this way, after we get the sum of the current level, we can add it to the level sums. So, and then we update the level. So level will be, so we are going to collect all the children nodes for the current level. So it's child for node in level, and for child in, say, node left, node right. So we just want to collect that those genuine ones. In other words, not now. So we use if child. So this updates the level, right? Then after this while loop, you are going to get all the level sums. So we can do a print statement to see what we get. Level sums. For this example, you are going to get 5, 17, 13, and 10. Looks right. But notice that those sums are not in sorted order. So we can sort those things. So level sums. We can do a sort. So here we are sorting from small to large. Then when we do the return, so we just need to return level sums a negative key. If the length of this level sums is greater than or equal to k, otherwise we're going to return -1, right? So let's comment out this part, and then let's do a test. Yeah, it passes all the cases. I would say you can also use traditional, this is also very traditional, I would say. You can use some stack, or you can use quill to do depth-based traversal or breadth-based traversal. You can also, for example, put some information like in the quill or stack. So you can put something like this, root and some level. So at the very beginning, so you start from 0, then you do while loop. But here is a very short-handed way to do this kind of traversal. So with this done, I guess that's basically about it for the current video. You can check out those two problems to apply the code here. With that said, I guess that's it. Thank you.